Hello, we are from Gokaraju Rangaraju Institute of Engineering and Technology. We are from IT department. Our internal guide is Nagendra Kumar sir, HOD of IT department. Our team members are Vaishnavi Maragari, Mayuri, Nikita. Our mini project is voice-based gender recognition using male frequency capstone coefficients and Gaussian mixture models. Coming to the abstract, our gender recognition is based on male frequency capstone coefficients and GMM models. Male frequency capstone coefficients are used to extract the features from the audio files. GMM models are used to train the machine learning model. We train both a female model and a male model. We specifically used EM algorithm, that is expectation maximization algorithm, in Gaussian mixture models. Our voice-based gender recognition using MFCC and GMM gives high accuracy and robustness. Our aim is to give accurate results for voice-based gender recognition. We use this voice-based gender recognition in customer care and voice assistant for better interaction. By finding out which gender is our customer, so that we can improve our interaction. Our existing system, we also have existing systems for voice based gender recognition, but they used LPC and methods like LPC and HMMs. They also give the results, but of less accuracy. They fail in noisy areas, and when the audio files are little bit noisy, they couldn't give the best results. LPC coefficients capture the vocal characteristics of speech signals and commonly used in speech coding and synthesis. HMMs also are also for the same usage. Our proposed system is using MFCC and GMM, which gives high accuracy and robustness. MFCC features are known for their robustness to background noises. Even though when we have noise when we are giving audio, it is very robust. Usually we have noise when we talk to someone else. So this MFCC is very accurate in providing the results, and GMM models also give very accurate results in training the models. GMM are probabilistic models that can represent the distribution of feature vectors extracted from voice samples. System specifications, we have both software and hardware requirements. Coming to the software requirements, we need Python 3.11 version in Visual Studio Code and libraries such as NumPy, Python speech features, scikit-learn, SciPy. For various applications like numerical applications, and for extracting MFCC features, and for GMM methods, and for all those. And we took our data set from the free ST American English corpus data set. It is an open source data set which will be available for all, and we took the utterances from 10 speakers, 5 males and 5 females. Each speaker has about 350 utterances. We used that for training and testing. Hardware, in we need 16 GB RAM with Intel i7 processor or higher, with a minimum hard disk size of 256 GB. This is a minimum requirement of hard. Coming to the design phase, we have different diagrams, UML diagrams. In that, first one is use case diagram. Use case diagram is a visual representation of interactions between users and the system. It illustrates the requirements of a system and shows how users interact with the system to achieve specific goals. Coming to the class diagram, it is a type of static structure diagram that describes the structure of a system, showing its classes, attributes, and operations. These are the classes, these are the attributes, and these are the methods or operations in that classes. It also shows the relationships among the objects. And our next diagram is activity diagram. It represents the flow of activities or actions within a system or process. It also shows how activities relate to one another. It is often used to model workflows and business processes, etc. Sequence diagram. Sequence diagram is a type of interaction diagram that shows how objects interact in a particular sequence of time. It represents the order of messages exchanged between objects to accomplish a specific goal. like how the data is exchanged between two objects, what action is happening. It explains in a sequence manner. Next, coming to the deployment diagram, it is a structural diagram that shows the physical deployment of a software components and modules on nodes. It illustrates the physical architecture of a system, including hardware components and software components. Whatever we have in our system project. Coming to our system architecture, it is a conceptual model that defines the structure behavior of a system. It is an overall framework for understanding the high level structure of a system, which includes its components and interactions. In our project system architecture, we take voice input and we process it and we extract the MFCC features and we train the GMM models, and we separate into male GMM model and female GMM model. Internally, we use expectation maximization algorithm for training the GMM models. We take the labeled data set for training the GMM models. For real-time applications, we extract the MFCC features and we match the percentages with the already trained models, GMM models. Whichever is higher will classify according to that matching percentage. We use that in real-time classification. This is the overall architecture diagram of our system, which includes training phase and testing phase. Coming to the codes and implementation, we have four main programs in our project. The first program is extracting the files and dividing into training and testing. Here in this extract dataset method, we extract the files from the tat file archive and we make a new directory here and we move files from source to destination. Next, we divide the dataset into training and testing dataset. Like this, we divide it into both training dataset and testing dataset, and we'll form a new folders for both of them. And then second program is features extractor, in which we extract the features from our files which we extracted from our in data manager program. We extracted the files. From that, we extract the features by reading the audio path and normalizing it and computing the delta and delta features. Next, we train the GMM models in models trainer program. We get the file paths from we get file paths from using the path female training path and male training path, and then we collect the features as we extracted from extract features method. Then we using that we train the GMM models for separately for both female and males. And then finally, in the gender identifier, we have a HTML page to post the audio file, and then matching it with the existing training data, already trained data. We match the percentage, then which is higher, then that will be the result. If the female percentage is higher, then the identified gender is a female, or else the identified gender is male. Coming to the execution, here we run.py will execute all of them together: gender data manager, feature extractor, and models trainer. Here it's training. We are training the female models. We are training here male GMM model. Yes, it's completed after saving the both females and males GMM models. Now we have to run the gender identifier file. We need to click it. We'll get the output like this. it shows a HTML page to upload a WAV file for gender recognition. Here we'll choose the file from the females testing data. Then we'll upload it and we'll get the results. We'll get the expected gender, identified gender is based on the female percentage and male percentage. This is a matching percentage. And also we'll get the bar graph with the female and male matching percentages. We can also upload another file here. Again we need to choose a file and upload. This is our project, voice based gender recognition using MFCC and GMM.